Hello everyone, welcome to Code Century. Today we will be solving day 6 HackerRank problems. The first problem is leap year checker. The difficulty is easy, so let's go ahead and read the problem statement. Write a program in Python to check whether a given year is leap year or not using the ternary operator. A leap year is a year is leap year if it is divisible by 400 or it is divisible by 4 but not divisible by 100. As an input, we get an integer representing the year, and in the output, print leap year if it is a leap year, print not a leap year otherwise. Very simple. The year value will be between 1 and 900 and 9999. So this is the sample case where when the input is 2000, the output is leap year because though it 2000 is divisible by 100, it is divisible by 400. So we can just write it as a leap year. But when it comes to 1900, the year 1900 is divisible by 100 but is not divisible by 400. So it is not a leap year. The reason behind this is because generally we assume that every 4 year is a leap year, but that would mean only the time required for Earth to complete one revolution around the sun is 365.25 days. But to be more accurate, it's actually 365.2425 or something like that. I don't really remember the exact. But to, increase that accuracy, this rule has been introduced where where if a year is divisible by 4, then it is leap year. But if it is divisible by 100, then it is not a leap year. But for every 400 years, then again it is a leap year. So going by these rules, so we will write a Python program now. First, we need to take the input of the year. So let's say year is equals to an integer input from standard input. Then we need to calculate if the year is a leap year or not. So let's take a variable known as leap and set it to false. So the sleep is a boolean variable. It will store only boolean values true or false. By default anyway, because most of the years are non-leap years anyways. So we will set it to false for now and then check if the year is a leap year or not. If the year when divided by 4 gives a remainder of 0, that is the year is divisible by 4, then we know that it is generally a leap year. So we set the leap value as true. But if a year that is divisible by 4 is also divisible by 100, because all numbers divisible by 100 are anyway divisible by 4, so we do not need to write these two if conditions separately. So if the year which is divisible by 4 is also divisible by 100, then according to what it is written over here, then that year cannot be considered a leap year. So leap will be again set to false. And the final case would be if the year is divisible by 400. So anything divisible by 400 will also automatically be divisible by 100. So inside this if condition of year being divisible by 100, we write year when divided by 400. If it gives a 0, then leap is set to true again, and thus this is the logic to find whether a given year is leap year or not. So by default, by rechecking the logic, by default the leap is false. If the year is divisible by 4, then it is set to 100. But if the year is divisible by 100, then because it's said that the year divisible by 100 are not leap years, so we again set the leap value to false. But if the year is divisible by 400, then again we will set the leap value to be true because that's the entry criteria given here. We write all the if conditions like this because generally all numbers which are divisible by 100, because here we are checking if the number is divisible by 100. All numbers which are divisible by 100 are also divisible by 4. So we can write it here, or we can write this condition inside this condition without compromising or leaving any edge cases. The same logic goes for checking 400 inside the condition of checking for divisibility by 100. And also by doing this, all of this comes under one single ladder, which actually reduces the variables which are created internally by Python, which we cannot see. They are done under the hood by the Python while checking these if-else conditions. By reducing these variables, the code is much more optimized, and also you are less prone to errors. Sometimes I experience that writing the ifs separately, sometimes you have a very slight chance of errors. So I suggest writing if it is possible, only if the given conditions can be satisfied like in a single ladder, only then try to go for a single ladder. It's much more better and efficient. So now that all the find calculations for finding if the year is leap or not are all done, and we have a Boolean variable called leap stating if the given input year is a leap year or not. We just need to use the ternary operator as given in the problem statement to display whether the year is a leap or not. So let's write the final in display statement. We print uh, leap year only if the leap value is true. Else, if it is not true, we print not a leap year. So there you have it. Here. This is a ternary operator in Python. So basically what we do is here we write a base case which will be printed if this condition is true. Only if this condition is true, then this case will be activated. If this is not true, then this will be activated. All right. So here we take the input in this line, and in this if else ladder, we check whether the given year is true, is a leap year or not. And now, if we're based on this condition, Python checks if the leap is true or not. If it is true, if the year is a leap year, then then this statement is executed. And else, if it is not, if this condition is unsatisfied, this condition returns a false. Leap is equal to true. So leap is actually false. Leap is not it is not a leap year. The year is not a leap year, then the leap will have a value of false. False is not equal to true. So this comparison will return a false. And if it returns a false, then this else statement is executed and we get the output of not a leap year. So let's check if this program is working as expected. Let's enter the input or sample input year 2000. It is a leap year because it is divisible by 400. But we also have one special edge case over here. The year 1900 is not divisible by 400. It is divisible by 4 but also divisible by 100. So it should be a non-leap year. So let's check that. Not a leap year. So we are also able to, you know, cover the edge case of year divisible by 100 not being a leap year. And with that, we have solved this problem. I hope you understood the concept that I tried to teach you here. So thank you. Let's meet in another video. So hello everyone, welcome back to Code Century. Today we will be solving day 6 HackerRank problems. The second problem, that is discount calculator. The difficulty is easy, so let's read the problem statement. A store offers discounts based on the total bill amount and customer type. Bill amount discount. If the bill is 5,000 rupees or more, then we get a 20% discount. If the bill is between 2,000 and 4,999, we get a 10% discount. If the bill is less than 2,000, then there is no discount. And in the customer type, if it's a premier customer, then he gets an extra 10% discount. And a regular customer will get no extra discount. The program needs to be written using if else conditions. So in the input format, we get bill amount in the first line. It can be integer or float. In the second line, we will get a string which is either premium or regular. So obviously, if the string is premium, we would need to add another extra 10% to the discount. Regular customer will not get any discount, obviously, as per what's written here. In the output, we need just the final bill amount after applying all discounts as a floating point. Okay, so first we need to take the inputs. So bill is a floating point from standard input. We casted this input as a floating point because even if it is an integer, it can be stored in floating point, can be considered a floating point. So where it will not be a problem. Also, since the end result is expected in float to be a floating point, already taking the input as a floating point will help us in the long run. And in the second line, we are expecting the customer type, which is already a string. So since standard input is read by the Python program as a string by default, we do not need to typecast it into string another time. And now we apply the actual dis discount logic using if else conditions. If the bill amount is greater than 5,000 rupees, the discount will be 20. Else if bill is greater than 2,000 rupees, which would automatically include the range from 2,000 to 4,999 because already we have checked if the bill is lower than 5,000. Since this is already checked, all the range from 2,000 to 4,999 is comes under this if condition, then the discount will be 10. Else discount is obviously 0. Now that we calculated the base discount based on the billing amount, we need to also consider what type of customer he is. If he's a premium, we need to add another 10%. So if type is equals to premium, or the premium gets back to P, then discount is equals to discount plus 10, which means we are adding another 10 percentage of discount to the customer since he's a premium payer. And now, since all the discount logic has been written, we need to output the final bill amount as a floating point. So we use the print command. We print bill minus bill into discount divided by 100. This formula gives us the final payable bill amount doing all the after calculating all the discount on the total bill. So to test this code, let's use these sample cases. Let's run this Python program. If the input is 6,000 rupees and the customer is a premium customer, then we get 4,000, then he gets a 4,200 rupees final bill, which is correct as per the first amplitude. And now let's run this again. 3,000 rupees bill, which means he gets a base 10% discount. And then the customer is a regular, so he gets only 10% discount, which means he will get a final bill of 2,700. Perfect. And now the bill is only 1,500, but the customer type is a premium. So we are expecting a 10% discount for the premium customer. So he paid only the bill is only 1,500, but he's a premium. So yeah, 10% discount, 1,350 rupees. So the program works as expected. I hope you understood what I'm trying to teach here. So thank you. I hope we meet again. So hello everyone, welcome to Code Century. Today we are solving day 6 HackerRank solutions. Third problem, that is traffic fine calculator. It's a very easy problem, so let's go ahead and read the problem statement. A city traffic rules In city has traffic rules with fines based on vehicle speed. Speed less than 60 km per hour has no fine. Between 60 to 80 has a 100 rupees fine. And above 80 we have a 200 rupee fine. We need to write a Python program using switch case, that is match case, that takes the vehicle speed as input, displays a friendly message including how much the driver is over the limit if applicable, the fine amount if any, a friendly warning or message. The input is just one integer which represents the vehicle speed in kilometer per hour, a human readable message indicating the fine status. So also the input is always an integer between 0 to 300. And in the sample cases, we can see what kind of human readable messages are expected out of us. So let's implement them. First, we need to take the input, which is just one integer representing the speed of the vehicle. So we will name it speed is equals to integer input. And now we need to calculate the fine and how much the driver is over the limit if he is over the limit. So let's write an if else step ladder for that. If the speed is greater than 80, then we know that fine will be 200 and difference would be speed minus 80. Else if the speed is greater than 60. So since this condition is already checked, though in when this con within this condition, the speed will always be between 60 to 80, exactly as we need for this condition. The fine will be 100 and the difference will be speed minus 60 because that's the limit in this condition. Else, if both are not true, that would mean the speed is below 60. For that, we would get a fine equal to 0 and difference. We will not have a concept of difference by then anyway. So we do not need to write a difference. And now for the output. For the output, we can use the match case statement which is available in Python. So let's see how that works. We first write match and the variable name over which we are switching cases, which is fine. And in the case that the value of fine is 0, we print no fine, drive safely. Drive safely. Because the duties are perfectly following all the traffic laws. He's driving below 60. So he gets no fine, and he's just reminded to drive safe. And in case that the value of fine is 100, which means the person was traveling at a speed somewhere between 60 to 80, in that case, we print that you are 10 kilometer per hour. This is the difference, the speed difference over the speed limit. So this is the speed limit. So the difference, you are 10 kilometer per hour speed limit and over the limit difference and kilometer per hour over the limit. The fine is rupees for the value of fine. In case the fine value is 200 rupees, we need to print that's mostly the same, but we also add please slow down message. So you are difference and kilometer per hour over the limit. Your fine will be rupees, whatever the fine you calculate. Oh, and also finally, please slow down. Yep, that is basically how it works. So for input of scientific. Okay, so based on this, we can see that even in this case, the speed limit should be considered to be 60 because, yeah, because that makes sense. All over the city, you are only supposed to drive at a constant speed of 60 or lower. If you are above 80, then you are getting an excess fine because you are speeding way too much. 60 to 80, you get a concession because you might be accidentally speeding without knowing it. So just 100 rupees fine. Okay, so that's why we only need to use, even in the case of speed above 80, the difference will be calculated by speed minus 60. So with that being the case, let's apply these sample cases over this Python program and check what if we get the expected output. When the speed is just 55, he's driving by following all the traffic rules. No, fine, drive safely. Nice. Now in the next test case, we get 70 as the speed of the vehicle, which means he is 10 kilometer per hour over the speed limit. So we get a kind of 900 rupees. Executing it another time with 90, which is above 80. So the highest fine will be applied to this person. Yep, and he gets the highest fine. He's 30 kilometer per over the speed limit and he gets a fine of 200. He also gets assigned to please slow down. So there we have it, a perfectly executed fine system for the city in the question. So I hope you understood how to use the match case in Python, and I hope you understood what the concept I'm trying to teach here. Thank you. I hope we meet in another video.